This is the other part of solving normal distribution questions from your past papers. Make sure you looked at the first part and attempted to solve the questions. Similarly here, make sure you pause the video, you attempt the questions, and then you look at the solutions that I'm going through. So for this question, it's a couple of parts, and I've separated them into different slides. The main idea is that Daniel grows apples and chooses at random a sample of 100 apples from his harvest. So we already have our total here as 100. We might use it later on if they want the expected value. So he measured the diameter of the apples to the nearest centimeter. The following table shows the distribution of diameters. So you have for each diameter 5, 6, 7, 8, 9, and you have the different frequencies. Use your graphic display calculator. So this should be the first indication that it should be a quick calculation. You need to find the mean of the sample and the standard deviation. Remember that you can find all of this using the stat calculate option, but before that you need to add your data to your list. So in order to go to your list, you go to, in order to edit your list, you go to stat, and then you press on edit, and then you get your lists. In order to clear a list, you need to go to the title of the list. So you scroll up until the L1 is, or L2, or whichever list, until the title of the list is highlighted, it's blinking, and then you press clear. And then you scroll down and everything else will be cleared. So we will write the lengths in L1 and the frequency in L2. That's typically how it's done. Don't swap them around just so that you avoid confusion. So this will be in L1. I'm going to write 5, 6, 7, 8, 9. L2 will be 15, 27, 33, 17, and 8. Make sure you write them in order. Once you're done, so you want your summary now of your data, you go to stat, and then you go next and you go to calculate, and then you press on the first option, which is one variance, stat. And this will give you a full summary analysis about all of your data. Now, if you have a wizard sort of image in your GDC and it says list, so you put your L1 in list, and if it says frequency list, you put L2, and then you go to calculate. If it doesn't have this, then you'd have to go to, go one variance, and then you'd have to pick your L1 and L2 in commas. So if it goes to the main page and it just writes that and expects you to write the list, then you should write L1 and then put a comma, and the comma can be found above 7, and then L2. If you knew all of this, you could have just skipped all this part. And then you go through the summary, you press enter, and you will get your values. So remember that X bar, which is your first value, is the mean. That's how we write the mean. And it is 6.76. Always remember the units, centimeters. And then the standard deviation, we will always want the sample standard deviation, so that's sigma x. That's the standard deviation. And in this case, it's equal to 1.141 centimeters. They didn't specify how many decimal places, so make sure you write them to as many decimal places as you're comfortable with. And this should be enough. So you write the values here, 6.76 centimeters and 1.4141 centimeters as a standard deviation. This should have been a quick question and you would have gotten easy marks on this. Now, for part B, Daniel assumes that the diameter of all the apples from his harvest are normally distributed with a mean of 7 and a standard deviation of 1.2. Important information here. And he classifies them in this way. Now, when they give you a weird table that you're not used to seeing, take your time to understand what they mean with each table. So it just says that if the diameter is less than 6.5, then it's classified as small. If it's between 6.5 and a specific A, then it's classified as medium. If it's greater than a length A, then it's classified as large. So again, it's always good to sketch all of this. So the mean is 7. And so if there's a apple with 6.5, anything underneath, anything that has a length less than this up to here is considered as small. And then everything from 6.5 to a specific A, let's say the A is here, for example, is considered as medium. And then everything above A is considered as large. So again, it's good to visualize all of this data. Now calculate the percentage of small apples in Daniel's harvest. So we need percentage and we need small apples. Small apples are all the apples that have less than 6.5. And for normal distribution, it doesn't matter if it has a less than or equal to, you use the same formula. So in this case, you should also note that you cannot get to 6.5 using the standard deviation of 1.2. I cannot subtract 1.2 to get to 6.5, and so 6.5 is not within the standard deviations, and so I cannot use the percentages that we've done in class, the 68, the 95, and the 99. And so the diameter, so we need to use the GDC calculator, so we go normal, CDF. Your minimum now, because the small is anything less than 6.5, so everything can be considered. So you go 1, -1, so we're going up to negative infinity, -1, E, 99. And then goes all the way up to 6.5. So this will be the range that you need. This will be the shaded area. And then the mean is 7 and the standard deviation is 1.2. You put this in your calculator and you should get 0.338 0.338, and then since it wants in percentage, you need to multiply it by 100, so 0.338 times 100, which is 33.8. You can leave it to more decimal places here if you want to. 1 decimal place should be enough. So this is your final answer, and we'll move on to the next one. Part C says that Daniel assumes that the diameter of all the apples, sorry, it's a repetition. Again, we have the same table, it's just a repetition. We're looking at this part. So of the apple harvested, 5% are large apples. Find the value of A. So if we use our diagram, this is 7. There's a specific A where the large consists of all of this area. And it tells you that 5% of the apples harvested, 5% are large apples. So all of this is considered as large apples. So this is, sorry, 5%. So you should be using the inverse normal distribution. So remember, if you have a newer calculator, you can just plug in the 0.05 into your inverse normal and you pick the right tail. If you don't, your calculator can only calculate less than A. You won't be able to calculate more than A, or use the value less than A. And so what we'll do is we'll calculate the inverse, which is 0.95. Remember that the whole area is 1 or 100%. So this is 95%. And then you plug this number into your calculator. So inverse norm 0.95, the mean of 7, and standard deviation of 1.2. It should give you the same value of A. It's just that your calculator, if you have the older ones, they won't be able to recognize if you're talking about more than or less than. So what it does is it just calculates the less than. But the value of A is still the same. The area below it is 0.95, which immediately means that the area above it is 5%, which is what we have. So Or in general, just remember the rule that if you're looking for greater than, you need to do the 1 minus before you start. You plug this into your calculator and you should get 8.9738. And you could leave it in this form. Remember to write the units down centimeters. For this part of the question, again, this information is repeated, and this is the question. Find the percentage of medium apples. So we've already found A to be 8.9738, so A is equal to 8.9738 centimeters. And medium is between, so this is 7, the medium is between 6.5 and 8.938. Let me just highlight the mean just so that it looks different from all of them. So, and the area we want is between those two values. Again, always sketch, because you might get 1 mark for the sketch, just showing that you recognize that this is the area you need. You plug these numbers into your calculator, normal CDF. This time you have a lower boundary of 6.5 and you have an upper boundary of 8.9738. Your mean is 7 and standard deviation 1.2. Write it in your calculator and you should get 0.6112. Now they want the answer in percentage, so remember to multiply by 100. So I'm going to do it on a separate line, 0.6112 times 100, which is 61.12%. And that's the final answer for this one. The last part is of this question. So this year, Daniel estimates that he will grow 100,000 apples. Estimates the number of large apples that Daniel will grow this year. We need to remember to use the values that we have. So remember that estimate is calculated by taking the total number you have multiplied the total times the probability. And so we have our total, which is 100,000. And then we need to calculate the probability. Estimate the number of large apples that Daniel will grow this year. Well, actually, we don't need to go through the calculation, because if you remember, they told us that the percentage of large apples is 5%. So I don't really need to do anything. You can try and find it if you want to. You use the A that you have and you put in your calculator and it should give you about 0.05. But it's going to be slightly extra work. Make sure you read all the questions. They've put it in bold for a reason. So the total is 100,000. This multiplied by 0.05, and it should give you 5,000 apples, and that's it. So what we're saying is, out of the 100,000 apples, we can expect that 5,000 apples will be considered as large. That's all the question is asking. Hopefully this video was clear, you were able to follow through. Do practice more questions from your math studies past paper booklet, and attempt some other questions online as well if you find any.